Hello everyone and welcome to the lecture on AWS Private Certificate Authority. So this lecture will contain all these topics. What is AWS Private CA? Regional availability for AWS Private Certificate Authority. Services integrated with AWS Private Certificate Authority. Supported algorithms. Trust. TLS server certificates. What is a certificate signature? Understanding certificate authority. Understanding root CA. CA and root CA certificates. And entity certificate, self-signed certificates, private certificate, and understanding certificate path. So what is AWS Private CA? AWS Private CA allows you to create your own private certificate authority hierarchies. This includes both root and subordinate CAs without needing to invest in or maintaining your own on-premises CA. With your private CAs, you can issue X509 certificates which are used in many different situations. These certificates help create encrypted TLS communication channels, making data transfer secure. Certificates can be used to authenticate users, computers, API endpoints, and IoT devices, ensuring only verified entities gain access. You can use certificates to cryptographically sign code, ensuring that the code has not been tampered with. Certificates support implementing the Online Certificate Status Protocol (OCSCP) to check if a certificate has been revoked. Regional availability for AWS Private Certificate Authority. Private certificate authorities, CAs, are like most AWS resources, they are regional resources. That means they are not global, unlike, for example, Route 53. Regional means they are similar to, let's say, EC2. To use private CAs in more than one region, you must create your CAs in those specific regions. So let's say you want to use in US East 1 and US West 2, you should create a private CA object in those two regions. You cannot copy private CAs between regions, so this is region specific. Services integrated with AWS Private Certificate Authority. If you use AWS Certificate Manager to request a private certificate, you can associate that certificate with any service that is integrated with AWS Certificate Manager. This applies both to the certificates chained to AWS Private CA root and to certificates chained to external root. You can also use integrated private CAs into Amazon Elastic Kubernetes services to provide certificate issuance inside a Kubernetes cluster. If you use the AWS Private CA API or AWS CLI to issue a certificate or to export a private certificate from ACM, you can install the certificate anywhere you want to use. So these are some of the very popular industry standard algorithms and signing algorithms which are being used. So these are all RSA 2048, 4096 EC prime. So these are some of the, just for your information purpose, and signing algorithm is SHA 256 and the CDSA RSA. So this is just for your information. Okay, what is a trust? For a web browser to trust a certificate, it needs to check the website's digital certificate. Browsers only automatically trust a few certificates called as CA root certificates. So if you have used a browser, you will see like VeriSign and some top level, they are called as root certificates, and your browser comes pre-installed with those root certificates. A certificate authority, which is a trusted outside party, checks who runs the website and gives the website operator a digitally signed certificate. The browser then looks at the digital signature on the certificate to confirm the website's identity. If everything checks out, the browser shows a lock icon in the address bar to let you know that the site is secure. Understanding TLS server certificates. For secure HTTPS connections, you need server certificates to prove that a server is really who it claims to be. A server certificate follows the X509 v3 standard and links the public key in the certificate to whoever the certificate is for. Signed by CA, a trusted certificate authority signs the TLS certificate. The certificate includes details like the server's name, how long the certificate is good for, the public key, and the method used to sign it. What is a certificate signature? A digital signature is basically a secret code made by encrypting a summary of the certificate. It makes sure the information in the certificate has not been changed. Your private CA uses a special math function like SHA-256 to create this code. This function works on the certificate content, which can be different sizes. The function produces a string of data that is a fixed size and cannot be faked, and this is called as a hash. It's a one-way, you can call one-way hash or one-way algorithm to produce. You have input and it will have a output which is fixed length. The CA then uses its private key to scramble the hash value. The result will then be combined with the original certificate. Understanding certificate authority. A certificate authority is responsible for issuing and, when needed, cancelling digital certificates. Most use the X509 standard. An X509 certificate confirms who the certificate belongs to. It could be a person, an app, a computer, or another device that links their identity to a public key. The CA signs a certificate by creating a summary of the content, which is hashing, and then securing this summary with a private key that is linked to certificate's public key. When a web browser needs to check a subject's identity, it uses the public key to unlock the certificate signature. It creates its own summary of the content and makes sure the hash matches the decrypted signature. AWS Private CA lets you create your own private CA, which you can then use to issue private SSL and TLS certificates. These are for use inside your organization because they are private, and before using a CA, you must create the appropriate certificate. Understanding root CA. A root CA is a fundamental element for security and serves as the foundation of trust for issuing digital certificates. So components, it has two main parts: a private key used for signing certificates and a root certificate which shows who the root CA is and links the private key to the CA's name. The root certificate is given to the trust stores of everything in a setup. Administrators create these trust stores to contain only the CAs they trust, updating them across all systems and devices. Connection attempts. So when things try to connect, they examine the certificates presented to confirm they are valid and that there is a path back to a root certificates in their trust store. Handshake. So if the checks pass, a handshake happens between the resources. It shows the identity of each to the other and creates a secure, encrypted way for them to communicate. And this happens using TLS SSL. CA and root CA certificates explained. So CA certificate, a certificate authority certificate confirms who the CA is and connects it to the public key in the certificate. You can make a private root or subordinate CA with AWS Private CA, and each has a CA certificate. Subordinate CA certificates. These certificates are signed by another CA that is higher up in the trust chain, but the root CA certificate is signed by itself. External root authority. So you can also have a main authority outside of AWS, like in your own office. Then you can use this main authority to sign a lower level root certificate that is AWS Private CA manages. Root CA certificate. So a certificate authority usually exists in a ranking system with other CAs, showing clear relationships between them. Lower CAs are certified by those above them, making a certificate chain. The top CA is the root CA and its certificate is the root certificate, usually self-signed. So all these certificates, so it's in a very big enterprise, if they are using private certificate authority, so they can set up, so they don't have to go to the internet, and they can set up a main private CA, and then let's say they have multiple servers, and then they can set up all this certificate, all this trust, all these things. Because if you do it through some other software, it's quite complicated, and there is a lot of maintenance headache. So this comes into picture. Let's say in an organization there are thousands of servers, and they have different client server model and trusting and all, so they can use this service. So this is very handy in those kind of situations. Next is end entity certificate. So end entity certificate identifies a resource such as a server, instance, container, or device. Unlike CA certificates, end entity certificates cannot be used to issue certificates. Other common terms for end entity certificate are client or leaf certificate. Now I'll talk about self-signed certificates. A self-signed certificate is signed by the person or entity creating it, not by a trusted certificate authority. This means it acts as its own authority. These certificates can encrypt data, ensuring that information is protected, but they cannot be used to confirm someone's or something's identity, and they cannot be cancelled once made. So from a security point of view, using self-signed certificate is not recommended. So despite the risks, many organizations use them because they are simple to create. You don't need special skills, and many applications will work with them. So if you have a private setup, you can still use them, but they are not so, because even within the organization, somebody can try to hack, or there can be some insider who may leak the data. So that's why it's not 100% secure. Organizations using these certificates face a higher chance of problems caused by expired certificates, because it is hard to keep track of when they expire, and there are no checks for creation. So what are private certificates? AWS private CA certificates are a special kind of SSL TLS certificates used only inside an organization. Unlike regular certificates, these are not trusted on the open internet. So this is what I talked about earlier. Identification, and these certificates help identify different things like computers, servers, apps, services, gadgets, and even users within the organization. So the private organization or an enterprise landscape itself have many devices and many components, and they can be used everywhere, but privately. Secure communication, so they help set up secure encrypted connections. Each device or user uses a certificate and some clever math to prove who they are to the others. Applications, and this is used in many places internally, like website connections, internal web servers, secure network access for users, and connecting various devices. Private certificates are not automatically trusted by everyone. A manager inside the organization needs to set up which apps should trust these certificates and ensure the right devices or services have these certificates. Understanding certificate path. So when a client uses a certificate, it checks if there is a clear path from the main certificate through any middle certificates and all the way to a trusted root certificate. The clients make sure that every certificate in this path is valid. It means checking each one to confirm it has not been cancelled, and also ensuring it has not expired. The client also verifies that the main certificate is intact and has not been changed, confirming its original state is maintained. It confirms the rules set within the certificate are followed. And that's all. Thanks for watching.